Let's take a look at the 1 kilowatt battery, so called because it produces electricity continuously, but is not a battery in the sense that we normally think of it. This device, which was patented by Harold Coleman and Ronald Selden Gillespie on the 5th of December 1956, is quite remarkable. It is a tiny, lightweight device which can produce electricity using a self-powered electromagnet and chemical salts. The working life of the device before needing refurbishment is estimated at some 70 years, with an output of about 1 kilowatt. No input power is needed, as the device produces excess electricity continuously. The operation is controlled by a transmitter which bombards the chemical sample with 300 MHz radio waves. This produces radioactive emissions from the chemical mixture, and those emissions continue for a maximum period of 1 hour. So the transmitter needs to be run for 15 to 30 seconds once every hour. The chemical mixture is shielded by a LED screen to prevent harmful radiation reaching the user. The patent GB 763062 is included below. This generator unit has an electromagnet, a tube containing a chemical mixture of elements whose nuclei become unstable as a result of the bombardment by short waves, so that the elements become radioactive and release electrical energy. The mixture being mounted between and in contact with a pair of different metals such as copper and zinc, and a capacitor mounted between those metals. The mixture is preferably composed of the elements cadmium, atomic weight 112, phosphorus, atomic weight 31, and cobalt, atomic weight 59. Those three elements are mixed by weight in the ratio 2 to 3 to 1. The mixture, which may be of powdered form, is mounted in a tube of non-conducting, high-heat resistivity material and is compressed between granulated zinc at one end of the tube and granulated copper at the other end, the ends of the tube being closed by brass caps and the tube being carried in a suitable cradle so that it is located between the poles of a magnet. The magnet is preferably an electromagnet and is energized by the current produced by the unit. The magnet is shown in the diagram below. Transmitter unit, which is used for activating the generator, may be of any conventional type operating on ultra shortwave and is preferably crystal controlled at 300 megacycles so that it does not need tuning. This is a picture of the front view and the side view of the unit. It is absolutely tiny. The quartz tube is less than 50 millimeters long, in other words less than 2 inches in length. So this distance from here to here is under 2 inches. The arrangement is you have this tube of chemicals. I've shown the end caps in red, and they are connected with wires which give you the output. That tube, should I say, is between two poles of an electromagnet, and the arrangement is very effective in the way that it operates. You have the schematic layout here. You have the output wire from the tube of chemicals. He specifies quartz tube as such. The electromagnets, are really two poles of one electromagnet, are shown outside this particular tube of chemicals, and there is a high frequency coil and a lead capacitor, and that is the entire schematic diagram of the operation. The transmitter unit is of any suitable conventional type for producing ultra short waves. The quartz tube containing the chemical mixture works best if made up of a number of small cells in series. In other words, considering the cartridge from one end to the other, at one end and in contact with the brass cap there would be a layer of powdered copper, and at the other end of that tube you have another brass cap which is in contact with zinc powder, and in between you got repeated amounts of copper powder, zinc powder, and the chemical mix which has already been specified. You can get about 14 cells in a single tube which is only 45 millimeters long and only 5 millimeters in diameter. In spite of its tiny size, this device puts out a kilowatt of electricity, that is 100 volts at 10 amps, and although it could be enclosed entirely in a box made of lead, as far as I'm aware it has never been replicated in the last 65 years. Here's the patent, and it is shown as an apparatus for producing an electric current. This patent shows the details of a lightweight device which can produce electricity using a self-powered electromagnet and chemical salts. The working life of the device before needing a recharge is estimated at some 70 years. The operation is controlled by a transmitter which bombards the chemical sample with 300 megahertz radio waves. This produces radioactive emissions from the chemical mixture for a period of 1 hour maximum, so the transmitter needs to be run for 15 to 30 seconds once every hour. The chemical mixture is shielded by a lead screen to prevent harmful radiation reaching the user. The output from the tiny device described is estimated to be some 10 amps at 100 volts DC. This invention relates to a new apparatus for producing electric current, the apparatus being in the form of a completely novel secondary battery. The object of this invention is to provide apparatus of the above kind which is considerably lighter in weight than and has infinitely greater life than a known battery or similar characteristics, and which can be reactivated as and when required in a minimum of time. According to the present invention, we provide apparatus comprising a generator unit, which includes a magnet, a means for suspending a chemical mixture in the magnetic field, the mixture being composed of elements whose nuclei become unstable as a result of bombardment by short waves, so that the elements become radioactive and release electrical energy. The mixture being mounted between and in contact with a pair of different metals such as copper and zinc, a capacitor mounted between those metals, a terminal electrically connected to each of the metals, means for conveying the waves to the mixture, and a lead shield surrounding the mixture to prevent harmful radiation from the mixture. The mixture is preferably composed of the elements cadmium, phosphorus, and cobalt, having atomic weights of 112, 31, and 59 respectively. The mixture, which may be of powdered form, is mounted in a tube of non-conducting high heat resistivity material and is compressed between granular zinc at one end of the tube and granulated copper at the other end, the ends of the tube being closed by brass caps and the tube being carried in a suitable cradle, so that it is located between the poles of the magnet. The magnet is preferably an electromagnet and is energized by the current produced by the unit. The means for conveying the waves to the mixture may be a pair of antennae which are exactly similar to the antennae of the transmitter unit for producing the waves, each antenna projecting from and being secured to the brass cap at each end of the tube. The transmitter unit is used for activating the generator unit and may be of any conventional type operating on ultra-short wave and is preferably crystal controlled at the desired frequency. The drawings here are numbered. This is a side view of the apparatus. It's interesting that the output wires, which are shown as 21 in this diagram, which is an end elevation of the actual unit, are also operating as an aerial to pick up the frequency that's been used to energize the chemical mixture. This is the circuit for the schematic of the entire system. As you can see, it's very simple. We come then to the description of the drawings. In the form of our invention illustrated, the generator unit comprises a base 10, which is here, upon which the various components are mounted. This base 10 having projecting upwards from it a pair of arms 11, which form a cradle housing for 12, which is a quartz tube 13. The cradle 12 preferably be made of springy material so that the tube 13 is firmly yet removably held in position. The arms 11 are positioned relative to the poles 14 of an electromagnet. Those are the poles there, each side of the tube. The electromagnet is marked as 15. The tube 13 is located immediately between the poles of the magnet so as to be in the strongest magnetic field created by the electromagnet. The electromagnet serves to control the alpha and beta arrays emitted by the cartridge when it is in operation. The ends of the quartz tube 13 are each provided with a brass cap 16, and these caps 16 are adapted to engage with the spring cradles 12 and the coil 17 associate with the magnet, being so arranged that if the base 10 of the unit is in a horizontal plane, the poles 14 of the magnet are in a substantially vertical plane. Also connected across the cables, or connected across the cradles I should say, is a lead capacitor marked 18, which may conveniently be housed in the base 10 of the unit, and connected in parallel with this capacitor is a suitable high-frequency inductive coil 19. The unit is provided with a lead shield 20 so as to prevent harmful radiation from the quartz tube, as will be described later. The quartz tube 13 has mounted in it at one end a quantity of granulated copper, which is in electrical contact with the brass cap 16 at that end of the tube. Also mounted within the tube and in contact with the granulated copper is a chemical mixture which is in powdered form and which is capable of releasing electrical energy and which becomes radioactive when subjected to bombardment by ultra-short-wave radio waves. Mounted at the other end of the tube and in contact with the other end of the powdered chemical mixture is a quantity of granulated zinc, which is itself in contact with the brass cap on the end of the tube, the arrangement being that the chemical mixture is compressed between the granulated copper and the granulated zinc. Projecting outward from each brass cap 16 and electrically connected to them is an antenna 21, each antenna 21 corresponding exactly in dimension, shape, and electrical characteristics to the antenna associated with the transmitter unit, which is to produce the ultra-short waves mentioned earlier. The electromagnet 15 is conveniently carried by a centrally positioned pillar 22, which is secured to the base 10. At the upper end of pillar 22 there is a crossbar 23, which has the high frequency coil 19 attached to one end of it. The other end of the crossbar 23 is bent around into the curved shape as shown at 24 and is adapted to bear against the curved portion 25 of the base 26 of the electromagnet 15. A suitable locking device is provided for holding the curved portions 24 and 25 in the desired angular position, so that the position of the poles 14 of the electromagnet can be adjusted about the axis of the quartz tube 13. The transmitter unit is of any suitable conventional type for producing ultra-short waves and may be crystal controlled to ensure that it operates at the desired frequency without the necessity of tuning. If the transmitter is only required to operate over a short range, it may conveniently be battery powered, but if it is to operate over a greater range, then it may be operated from a suitable electrical supply, such as the mains. If the transmitter is to be tuned, then the tuning may be operated by a dial provided with a micrometer vernier scale, so that the necessary tuning accuracy may be achieved. The mixture which is contained within the quartz tube is composed of the elements cadmium, phosphorus, and cobalt, having atomic weights 112, 31, and 59 respectively. Conveniently, these elements may be present in the following compounds, and where the tube is to contain 30 milligrams of the mixture, the components and their proportions by weight are 1 part of CO, 2 parts of CdCl2, and 3 parts of 3Ca PO3 2. The cartridge, which consists of the tube 13 with a chemical mixture in it, is preferably composed of a number of small cells built up in series. In other words, consider the cartridge from one end to the other. At one end and in contact with the brass cap there would be a layer of powdered copper, then a layer of the chemical mixture, then a layer of powdered zinc, a layer of powdered copper, etc., etc., with a layer of powdered zinc in contact with the brass cap at the other end of the cartridge. With a cartridge of some 45 millimeters in length and 5 millimeters in diameter, some 14 cells may be included. The cradles 12, in which the brass cap 16 engage, may themselves form terminals from which the output of the unit may be taken. Alternatively, a pair of terminals 27 may be connected across the cradles 12. These terminals 27 being themselves provided with suitable antenna 28, which corresponds exactly in dimensions, shape, and electrical characteristics to the antennae associated with the transmitter, these antennae 28 replacing the antenna 21. In operation with the quartz tube containing the above mixture, located between the granulated copper and the granulated zinc, and with the tube itself in position between the poles of the magnet, the transmitter is switched on, and the ultra-short waves coming from it are received by the antenna mounted at each end of the tube and in contact with the copper and zinc respectively. The waves being thus passed through the copper and zinc and through the mixture, so that the mixture is bombarded by the short waves, and the cadmium, phosphorus, and cobalt associated with the mixture become radioactive and release electrical energy which is transmitted to the granulated copper and granulated zinc, causing a current to flow between them in a similar manner to the current flow produced by a thermocouple. It has been established that with a mixture having the above composition, the optimum release of energy is obtained when the transmitter is operating at a frequency of 300 MHz. The provision of a quartz tube is necessary, for the mixture evolves and produces a considerable amount of heat while it is reacting to the bombardment of the short waves. It is found that the tube will only last for 1 hour, and the tube will become discharged after an hour's operation. That is to say, the radioactiveness of the tube will only last for 1 hour, and it is therefore necessary, if the unit is to be run continuously, for the transmitter to be operated for a period of some 15 to 30 seconds duration once every hour. With a quartz tube having an overall length of some 45 millimeters and an inside diameter of 5 millimeters and containing 30 milligrams of the chemical mixture, the estimated energy which will be given off from the tube for a discharge of 1 hour is 10 amps at between 100 and 110 volts. To enable the tube to give off this discharge, it is only necessary to operate the transmitter at the desired frequency for a period of some 15 to 30 seconds duration. The current which is given off by the tube during its discharge is in the form of direct current. During the discharge from the tube, harmful radiations are emitted in the form of gamma rays, alpha rays, and beta rays, and it is therefore necessary to mount the unit within a lead shield to prevent the harmful radiations from affecting personnel and objects in the vicinity of the unit. The alpha and beta rays, which are emitted from the cartridge when it is in operation, are controlled by the magnet. When the unit is connected up to some apparatus which is to be powered by it, it is necessary to provide suitable fuses to guard against the cartridge being short-circuited, which would cause the cartridge to explode. The estimated weight of such a unit, including the necessary shielding per kilowatt-hour output, is about 25% of any known standard type of accumulator which is in use today, and it is estimated that the life of the chemical mixture is probably in the region of 70 to 80 years when under constant use. It will be seen that we have provided a novel form of apparatus for producing an electric current which is considerably lighter than the standard type of accumulator at present known, and which has an infinitely greater life than the standard type of accumulator, and which can be recharged or reactivated as such and when desired, and from a remote position, depending on the power output of the transmitter. Such form of battery has many applications.